In this video we will go through the steps of the boot sequence, and we will explain all the processes in each step, and what the startup file and linker do to allocate all the sections to the correct places in memory. Let's start out video. The text section represents the executable code of the program, containing machine instructions for its logic. It's read-only in memory to maintain security and prevent modification during execution. This section often holds the program's entry point for execution. Linker scripts define how sections like text are organized in the final executable file. The constant global variables and string constants in the raw data section. Since raw data contains read-only data, it can be placed in flash memory instead of RAM. And we have three types of the initialized variables: global and global static variables and local static variables. The compiler places it in the data section. Data copying from flash to RAM during the initialization phase is a fundamental step in embedded systems and other memory-constrained environments. And the linker script specifies that the data section should be placed in RAM but loaded from ROM to improve the balance between storage and execution speed. Let's explain this approach because this is common in embedded systems. During the loading process, the linker transfers code to a ROM for storage. And when the program runs in a bare metal environment, the code is executed from RAM. This arrangement enables efficient execution since RAM access is faster than ROM. The SRAM at greater than flash notation suggests that the code is loaded into static RAM at runtime, optimizing performance by leveraging RAM's speed while using flash memory for storage. It optimizes data access times, enabling the program to efficiently work with initialized data and facilitate read-write operations on variables throughout its execution. This process is typically handled in the startup file. Now all uninitialized global variables are guaranteed to be initialized to 0. And when the code is compiled, a separate section called BSS is used to store these uninitialized variables. After all these allocated sections in memory, this is the time for the important part before starting and executing, which is to create a stack and make a stack pointer pointing to the top of the stack. And then reset handler. After it has finished all its initializations of memory, it will go to the main function to start executing the bare metal program. So now we all know the steps of the boot sequence correctly, and we are happy with this. If you are happy with us, please follow our page. Thanks for watching.